Okay, so let's look at this question, and hopefully doing this one will help you through this process. Um, so you're conducting a test to the claim test of the claim that the row variable and the column variables are dependent in the following contingency table. Now, our null hypothesis is always that they are independent, and the alternative is always that they are dependent. So we're going to do this process for all of these types of problems. So first, though, what I'm going to do is take this and I'm going to move it over to Word and make a table for it because we're going to need additional information to do these expected frequencies. So let me pull up the table that I made. All right, so here's that same information that I have just pasted into, really, I had to draw it into Word. All right, now what we're going to do is totals. You'll notice I put a total row in and a total column in. And I'm going to take everything in row A here and I'm going to add it up 11, 49, and 29. And that total is 89. I'm going to put that right here. And then I'm going to do the same thing for row B. 19 plus 52 plus 24 is 95. And then now I'm going to total up the columns. So 11 and 19 is 30. Um, this should be 49 and 52 is 101. And let's see, this should be 53. All right, now I will go ahead and total up. Now, whether I total all of the rows or all of the column, it should add up to the same thing. So 89 plus 95 is 184. And I can always check and make sure that if I add in the other direction, the 30 plus 101 plus 53 should also be 184, which it is. But that will tell me if I made a silly mistake entering something in the calculator, if those two totals are not the same. Okay, now that I've got those, here's what I'm going to do. I'm going to make a little space here. And let's notice that this 11, if we go over here to the right, the total is 89. And if we go down below it, the total is 30. I want to take 30 times 89, those two totals, and then divide them by the 184 that is the entire total. And if I do that, 30 times 89 divided by 184, I get 14. I get 14.51087. Now, I don't know what it said to round these expected values to, but we can do that when we go back. All right, so same thing for this next one. I'm going to look across from 49. This total is 89, and then down below 49, it's 101. So I'm going to do 89 times 101 divided by 184. And that is 48.85326. All right. Now, Z, exactly the same thing. If I look to its row, it's 89, and if I look to its column, it's 53. Um, 89 times 53 divided by 184. And that ends up being 25.63587. All right, so now I go to row B and do exactly the same thing. Across from the 19 is a 95 total, and down below it is a 30 total. So I want 95 times 30 divided by 184. And that's 15.48913. Same thing here. We want to do, beneath it is a 101, across from it is a 95, so we want to do 95 times 101 divided by 184. And that is 52.14674. And then lastly, let's do this 24. Down below it is a 53, and across from it is a 95. So we want to do 95 times 53 divided by 184. And that is 27.364, 0.36413. So each of these new values that we got are the expected value that we're going to put in the table. So 14.51087 we would put right there, but we're going to round it to 3 decimal places. So 14.5, what was it again? 14.511 would be what I put into that expected value table. And we'll do it for each of those that we just got. Okay, so that's how we fill out the expected frequency table. Now, let's talk about getting the chi-square test statistic. And then we'll move on to the critical value. So the chi-squared test statistic, let's go back to where I made all these calculations. And I'm just going to put test statistic rather than put chi-squared. Okay, so we are going to take the original outcome of 11 and subtract the new expected value that we got and square it. And then we'll divide that by the new expected value, 14.51087. And we're going to do that for every single cell. So we're going to have 49 minus 48.85326 squared divided by the new value, 48, divided by 48.85326. And then we're going to have the 29 minus 25.63587 squared. And we can probably put these in actually as the new values that we rounded them to for that expected values chart. That might make things a little bit easier. Divided by 25.63587. And then we're going to do the next row, 19 minus 15.48913 squared, except I can't type apparently, divided by 15.48913. And then we're going to do 52 minus 52.14674 squared divided by 52.14674. And then finally 24 minus 27.364, and somewhere along the way I goofed there. I'm not sure exactly how, but that should not be that. Maybe you can catch it as I was saying it earlier. 364, and oh, I forgot to square this. Squared divided by 27.364. And then we've done that. Once we do that entire calculation, that is our chi-squared test statistics. So you're going to have to go through and do each one of these terms separately in the calculator, get that answer, and add them all up. And that will be your chi-squared statistic. All right. Now, let's go to the critical value. Now, before we do our critical value in Excel, we want to get the degrees of freedom. The degrees of freedom are always going to be the number of rows minus 1. So we have 2 rows minus 1. Don't count your total, just your A and B here. And then we have X, Y, Z, 3 columns. Don't count the total column, minus 1. So it's 1 times 2. Our degrees of freedom are 2. So we're going to get the chi-squared distribution. We were told that alpha is 0.10. So let's go get the chi-squared distribution out of Excel. Okay, so we are going to go into Excel. We're going to type equal rather chi inverse, and we're going to put in that our alpha was 0.10, our degrees of freedom were 2, and close it. And that is 4.60517. Now, all chi-squared tests are right-tabled. So what we want is our rejection region is to the right of whatever our chi-square critical value is. So if what you get from your test statistic is bigger or to the right of 4.6, then it's in the rejection region, meaning that our variables are dependent. If it's to the left, then it's not in the rejection region and our variables are independent. All right, so let's go back here, and depending upon what you get, you will make your conclusion whether it's dependent or independent. Remember that our null hypothesis is that they're independent, and our alternate is that they are dependent. All right, so that's how to work through these problems, and hopefully that will help you with these.